All right, today we're going to take a look at topic 1.16, working with the intermediate value theorem. So the intermediate value theorem is the first of our value theorems in calculus. You can see here below, one of the first important existence theorems that we will study this year in calculus is called the intermediate value theorem, or for short, the IVT. Like all existence theorems we will study, the IVT relies on the continuity of a function. What does that mean? That means that a function has to be continuous in order for this theorem to work. So here's the theorem. If f is continuous on the closed interval a to b, including a and b, and k is some number between f of a and f of b, then there must be at least one number c on the interval a to b such that f of c equals k. What does that mean? Let's take a look here. Here we have a picture of what we can see a continuous function on this interval. Okay, and we're going to take some number k that is between f of a and f of b. Whatever this number k is, it is impossible for the function to skip over k. It must hit that k value at least once. Now, in this picture, it hits it 1, 2, 3 times on its way to b, f of b. But all it has to do is hit it once. That's it. And that's the intermediate value theorem. So since f is continuous, there exists at least one c, in this case 3, such that f of c must equal k. Here's a picture of a function that's not continuous, and you can see why the IVT is dependent on continuity. If the function is not continuous, then the function could absolutely skip over k on our way from a to b. Example 1. The function f is continuous on the interval -3 to 9. We know f of -3 is 0. We know f of 9 is -12. Which of the following would be a correct statement concerning the existence of a value c by the intermediate value theorem? Okay, so we know that since the function is continuous, therefore the IVT would work here, would apply. We know that f of -3 is 0. So if we want to just a quick sketch of this, f of -3 would be 0, and f of 9 would be -12. We're saying which of these must or could be a true statement here. Could f of 12 be 0? Well, it could. F of 12 could be 0, but the problem is we don't really know anything outside of this frame, -3 to 9. So we can't really say that. Could -1 be -13? Sure, it could. But again, the problem here is this is -3 to 0, and this is 9, -12. -1, -13 could exist, but we don't know for sure if it has to. So that's not it. -2, -10. There's -2, -10. That is definitely a possibility, right? If it's going from here to here, it could hit -2, -10. And f of 8, 1. So 8, 1, again, that one's not inside our range here. So could that be true? Sure. But the only one that fits with the intermediate value theorem would be C. Example 2, using the intermediate value theorem to show the polynomial function x cubed plus 2x minus 1 has a 0 on the interval 0 to 1. All right, so the first thing we have to make sure is f continuous, okay? And it's just a cubic function. And you know from your previous math classes that a cubic function will always be continuous. So we say f of x is definitely continuous on that interval 0 to 1. It's continuous everywhere, but it's definitely continuous on the interval 0 to 1. So therefore, we know the IVT does apply to this problem. Okay? So it says, show it has a 0 on that. So let's find f of a and f of b. F of 0 and f of 1. Well, f of 0 would be 0 plus 0 minus 1, so minus 1. F of 1 would be 1 plus 2 minus 1. 1 plus 2 being 3, minus 1 would be 2. So f of 1 would be 2. And the question is saying, show that there has to be a 0 on this interval. Okay, let's just think about this for a second. If you have a graph that goes from 0, -1 to 1, 2, and it's continuous, doesn't it have to cross 0 somewhere along the way? And the answer is yes. Now we just got to say how we write this out. Okay, so since IVT applies, we are guaranteed that there's a C value on the interval 0 to 1 such that f of x would change signs on either side of that C. Because we know f of 0 is -1 and we know f of 1 is 2, there must be a C value on 0 to 1 such that f of c equals 0. All thanks to the intermediate value theorem. All right, example 3. If f of x equals 2x minus 8 over x squared minus 4, is there a value c on 0, 3 that you are guaranteed such that f of c equals 2? If not, explain why. If so, find it. All right. So the first thing we got to see is this function continuous on the interval? Well, this is a rational function. It's definitely not continuous everywhere. Okay, so let's see where it is not continuous at. So if we factor, we get 2 times x minus 4 over x plus 2, x minus 2. So this function is not continuous at x equals -2 and x equals 2. We have to check and see if either of those are on the interval we're looking for here. And yes, one of them is. X equals 2 is on that interval. So this means that f of x is not continuous on 0 to 3. Which then tells us, therefore, the IVT does not apply. Could there be a value on that interval that f of c would equal 2? It's possible, but does there have to be? There does not, because the fact the function is not continuous. All right, example 4, again, we have a rational function here. So let's see where it's not continuous at. It's not continuous at x equals -4. Is -4 on our interval here? It is not. So therefore, we could say f of x is continuous on our interval. So f of x is continuous on the interval 1 to 4. So therefore, the IVT does apply. Okay? So next thing we're going to do is we're going to find f of 1 and f of 4. So f of 1 would be 2 minus 7 over 1 plus 4. F of 4 would be 8 minus 7 over 4 plus 4. All right, so our values are -1 and 1/8, and we are pretty sure that -1 is less than 0 is less than 1/8. So 0, which we got from here, is in that range of answers there, which tells us that the IVT is going to work for this problem. So we are definitely guaranteed that there's going to be an answer for this problem. Okay? Now we've got to find it. So how do we find it? We set our function equal to our k value. So 2x minus 7 over x plus 4 equals our k value, which in this case is 0. Multiplying both sides by the denominator, we get 2x minus 7 equals 0. So 2x equals 7, or x equals 7 over 2, 3.5. The last thing you got to check is the answer on the interval we are provided, which it is. So that means our c value for this problem is 3.5, or 7 over 2. Example 5. It's the same as the last problem here. So it's just a quadratic, we definitely know the function is continuous because quadratics are always continuous. There's no holes, no jumps, no asymptotes in a quadratic function. All right, so let's find f of 0. That would be -1. And then f of 5, which is 29. And our k value here is 11. Again, pretty obvious that 11 is between those two numbers. So because of all that, we know that the IVT will apply on this problem. And now we can find it. So to find it, we set our equation equal to our k value and solve. Start by subtracting 11 from both sides. Factor. And we get two x values. However, again, we have to make sure those are on the interval we are looking at. We are looking at 0 to 5. This is not on that interval. So our answer for C is 3. Okay, example 6, we have a table of values for function f here. It says function f is continuous for all numbers. So part A says, explain why there must be a value for x is between 2 and 4, such that f of k equals -1. All right, so since f is continuous, we know the IVT can apply to a problem like this. Let's check to make sure. We know f of 2 is 6, and f of 4 is -5. And pretty obvious that -1 is between those numbers. So therefore, by the IVT, there must exist a C value somewhere on that range such that f of C must equal -1. Well, I said f of k, so sorry, let's change that to f of k is equal to -1. All right, so because f is continuous, and because -1 is between -5 and -6, there must be an f of k equal to -1 somewhere on this interval. By the IVT. Part B says, what is the minimum number of times between 1 and 5 the function must equal 0? And how do we know that? All right, so let's see. Going from 1 to 2, does the function have to cross 0? It does not. Going from 2 to 3, does the function have to cross 0? It does not. Going from 3 to 4, does the function have to cross 0? And yes, it does, because 0 is between these numbers. So that's 1. And then going from 4 to 5, does the function have to cross 0? And again, the answer is yes, because 0 is between those numbers. So the answer here is twice. One time between 3 and 4, and one time between 4 and 5. So how do we know that? Because of the IVT. Because this function is continuous. All right? So since f is continuous, and since 0 is in between these numbers, and 0 is in between these numbers, it has to happen twice because of the IVT. All right. And we're going to end today with an old AP question here. We got a table of values. It says the functions f and g are differentiable and therefore continuous, which is really all we need to know for this problem, for all real numbers, and g is strictly increasing. The table above gives the values of the functions for their first derivatives at selected values of x. The function h is given by f of g of x minus 6. Okay, so h of x equals f of g of x minus 6. Little note there, the term differentiable, we still don't know what that means. The f prime of x, g prime of x, we still don't know what that means. We'll learn those later. But they're not pertinent to the question that we're going to answer below here. Okay? There are other parts to this problem that they are pertinent to, but I don't have those other parts here. All we're worrying about is part A here. Okay? So it says explain why there must be a value r for r between 1 and 3 such that h of r equals negative 5. All right, so let's start here. Let's make sure h is continuous. So remember, h of x is f of g of x minus 6. Okay, since f is always continuous and g is always continuous, the composition of those would be continuous as well. So we know h of x is also continuous. So it's definitely continuous between 1 and 3. Then we got to find h of 1 and h of 3. So h of 1 would be f of g of 1 minus 6. Look back at your table. G of 1 is 2. So that would be f of 2 minus 6. And then what's f of 2? 9. So that would be 9 minus 6, which is 3. Now let's repeat that for h of 3. F of g of 3 minus 6. G of 3 is 4. So f of 4 minus 6. And then f of 4 is negative 1. So sorry about that. Negative 1 minus 6 is negative 7. So the question is the k between those two numbers? It sure is. Negative 5 is greater than negative 7, but less than 3. So therefore, the IVT would apply here. So because negative 5 lies between negative 7 and negative 3, there must be an R value between 1 and 3 such that h of r would equal negative 5 by the IVT. Okay? That'll do it for our look at the intermediate value theorem. Thanks for checking in.